Good afternoon. Today I'm going to be giving a short introduction to load balancing. Here's a simple server that we are all familiar with. It takes only one request at a time, and if you were to send multiple requests in quick succession, that means the subsequent requests will have to wait in the Node.js event queue in order to be processed. But the question is, what if there are so many requests coming in very quick succession? The answer is that your server is going to be overloaded. So this is a response time graph of a server that is dealing with a non-trivial task that takes some processing time. You can see that on the left-hand side of the graph, the initial response time is under 500 milliseconds. But when you're sending in many more requests very quickly, some of the response times go over 2.5 seconds, almost 3 seconds. And you definitely don't want that to happen to your app. So as developers, an easy way of fixing that problem is to have multiple servers. Just spread the load across multiple individual servers, and they're all going to work together. But there's another problem that we have to, or a question that we need to ask ourselves. How are the servers going to coordinate themselves? Because the simple server that I showed you as the first slide, they currently don't really have a way of communicating with each other. So that's why I need something like a load balancer. A load balancer is basically what is going to distribute the load. It can be a server or a device. So this way, the servers can have a central location where they can get the requests from. So as shown in the diagram, the load balancer is going to sit between the client and the application web server instances. And another question that we need to ask themselves when we decide to use a load balancer is, how is the load balancer going to decide which of the web server instances are going to take the next incoming request? There are many ways to implement this, but the easiest way is to use something called round-robin algorithm. So in the implementation that I'm going to show you shortly, the load balancer is going to be listening on port 8000. And the 3 server instances that I'm also going to launch are going to be listening on ports 8001, 8002, and 8003. So this means, since this is a round-robin load balancer, whenever I send the request to the load balancer listening on port 8000, the ports 8001, 8002, and 8003 are going to each take in a request in a sequential manner. So this is where I'm creating a simple server instance. These basic servers are going to respond with hello world to every single request that comes through. In addition, these servers are going to console log that they have received a request. So next, we're ready to implement a load balancer. There are many tools out there that you can use to implement your load balancer, but the simplest tool that I found was something called Node HTTP proxy. And it's especially appropriate because I'm going to run everything on my computer, and I only need to support Node. If you needed something that has additional features or has to have bigger power, then you'll be looking into these other services. So this is where I'm going to require Node HTTP proxy and then launch a proxy server that's going to act as a node balancer. Next, I'm going to register the server instances that we're going to use in rotation. So here, I have an array of server addresses. And next, what I need to do is actually choose one of the servers from this array and then set that as a target. So on each request, we're going to grab a server from the address list, and then we're going to push the incoming request to that chosen server. Afterwards, the target server is going to be pushed back into the addresses array for future use. So now I'm going to show you what that looks like when I run it on the terminal. So here I already have the 3 server instances running on the background. Now I'm ready to launch my load balancer. I'm going to launch it on 8000. So this means whenever I send a request to the port 8000, we should also see some kind of response back from ports 8001, 8002, and 8003. So there it is. The proxy, or the load balancer, is balancing the request to 8001, and the subsequent requests are sent to the other servers that we have registered, and they're going to take in the request in a sequential manner, or in a round-robin manner. Oops. Okay. And with just that simple load balancer, now our response time graphs are significantly better. On the left-hand side is a graph that I showed you in the beginning of the presentation, and on the right-hand side is 3 servers working together with a simple load balancer, that's working in a round-robin fashion. You can see that even the highest response time is not going over 1 second, which is a significant improvement from nearly 3 seconds that we had previously. But we can do better. In the particular implementation that I showed you, the individual servers were hard-coded into the load balancer. So this means if you wanted to add or subtract any of the servers, that means we will have to stop the load balancer and then relaunch it, which is not ideal. Another problem is that if one of the registered servers were to crash, every third request will fail. That is because the load balancer has no way of knowing whether all these registered servers are actually running. So a better solution is a load balancer that automatically discovers which of the servers are running currently. And something called cport, it's a service manager which maintains the duplicated list of running servers. Something like cport is going to help you build a load balancer that overcomes these problems. And there are even more tools out there, like I said. Something like nginx is very popular, so is HA proxy. In addition, there are a lot of other load balancing algorithms like weighted round robin or least connected or IP hash that I'm not going to go into in today's talk, but I encourage you to look into them when you're implementing something like a load balancer for yourself. Thank you.